Okay, welcome. Today we are going over 5.4 factoring quadratic expressions. So let's take a look at if we can just take out a greatest common factor. The greatest common factor, the GCF. And that is going to be where the greatest common factor of an expression is the common factor with the greatest coefficient and the greatest exponent. Okay, so let's take a look at those at first. Finding common factors. We can look here and see, okay, what number or coefficient goes into 4, 20, and negative 12? Well, we should see that a 4 goes into all of those. An x cannot be taken out because this last term does not have an x. So we're left with an x squared. When I take something out, it's the same as dividing it out and just writing our greatest common factor in front. We can't just not write it because it's an expression. It's not an equation. So you can't just divide it and get rid of it. Okay, so 20x divided by 4 is a 5x. And negative 12 divided by 4 is a negative 3. If you were to distribute this 4 back in, you'll get back to the original trinomial. All right, moving on. If we look here, we want to look to see what can I take out from both a 9n squared and a negative 24. We should be able to see that I can take out a 3n, and then I'm left with a 3n minus an 8. Okay, and those are factored. Moving on here, let's take a look at when we have a quadratic trinomial in the following form. We've gone over this form. This is standard form, and we are going to factor it. We're going to factor it by finding the two factors that have a product of a times c. So we say what multiplies to a times c, and a sum of b. It adds up to b. So it multiplies to a times c, and it adds up to b. So when the value of a is a 1, you don't have to do a times c. It's just you say what multiplies to 7 and adds up to 8. So we have 1 and 7 multiplied to 7. We also have negative 1 and negative 7 will multiply to 7. The one that works is 1 and 7 because 1 plus 7 adds up to 8. And that's when you can go straight to the two binomials and write it as an x plus 1 times an x plus 7. This is factored. We have two binomials that are linear that when we multiply them out, it will give us this quadratic. We can check our answer. So we can check by multiplying these out. So we should know that when we multiply two binomials, I'm going to FOIL them. So I go first, x times x is an x squared. Outer, x times 7 is a 7x. Inner will give me an x. And last, 1 times 7 is 7. This is checking our answer. 7x plus an x is x squared plus 8x plus 7, which gives us back to our original solution. Okay, let's try another one here. So we want to know, again, the value of a is a 1. So when a is 1, you just are going to say what multiplies to your c, 72, and adds up to negative 17. So you can write down some factors here. Since it has to multiply to a positive and it has to add up to a negative, we know that our two numbers are both going to be negative. So you can just start by writing some factors that multiply to positive 72. Negative 1 and negative 72, negative 2 and negative 36, negative 3 and 20, negative 3 and negative 24, negative 4 and negative 18. Let's see what else. Negative 6 and negative 12. And negative 8 and negative 9. So we want to know which pair will add up to a negative 17. And we should see that the pair that adds up to negative 17 is negative 8 and negative 9. That adds up to a negative 17. So we go straight to our two binomials, x minus 8 times x minus 9. And that's our answer. Okay, for this one here, we say what multiplies to negative 12 and adds up to negative 1. Hopefully we're getting this down by now, and we should be able to see, okay, if it has to add up to a negative and it multiplies to a negative, then we're going to have 1 will be positive and 1 will be negative. That will be a negative 4 and a positive 3, because negative 4 times 3 is negative 12, and negative 4 plus 3 is a negative 1. Okay, let's try maybe one more of these. If we take, for example, this one right here, has to multiply to 8 and add up to a negative 6 here. So we know that they both are going to be negative. So we could take x minus 4 and x minus 2, because negative 4 times negative 2 is 8. Negative 4 minus 2 is a negative 6. Okay, moving on. This one is a little bit different. So this is when a is not equal to 1. So now we actually have to do a times c. So we're going to go 3 times 5, because this is in the form of ax squared plus bx plus c. So my a is 3, my c is 5. So that's going to be 15. Okay, so now I want to say, what multiplies to 15 and adds up to negative 16? Is it negative 1 and negative 15? Or is it negative 3 and negative 5? So the one that works is the negative 1 and negative 15, because negative 1 minus 15 is negative 16. All right, the next step here is we're going to rewrite the term, the bx term. So we're going to replace this negative 16x here with the 2 we just found, the negative 1x minus 15x. I'm going to replace this here and just rewrite it. Okay? So when we do that, I'm going to get 3x squared minus 1x minus 15x plus 5. Alright, so here's where it's also a little different. We're now going to take a look at the first two terms. And I'm going to say, well, what can I take out from these first two terms? I can take out an x. So when I take out an x, I'm left with a 3x. When I take out the x, let's divide it out. 3x squared divided by x, we're left with a 3x. Negative 1x divided by x, we're left with a negative 1. Here's the thing. Now we're going to take a look at the last two terms, but we know that I have to have this same binomial left over. So I'm just going to go ahead and rewrite it. And now I'm going to say, okay, what can I take out from these last two terms in order to have a 3x minus 1 left over? So if I take out a negative 5 here, look what happens. Negative 15x divided by negative 5, that's a 3x. 5 divided by negative 5 is a negative 1. Okay, so then we're almost there. Now we'll say, what did we make both of these have in common? Well, we made both of them have a 3x minus 1. So let's write that in front. So if I take a 3x minus 1 out from this first part, I'm left with an x. And if I take out this 3x minus 1 from the second part here, I'm left with just the minus 5. And this is factored. Okay, and remember, you can always check it by multiplying your two binomials using FOIL, first, outer, inner, and last, and you'll get back to your original quadratic trinomial. Let's try another one like that. So we could take this one here. We do a times c, 2 times 12 is 24. And I say what multiplies to 24 and adds up to 11. Okay, so we should be able to see, okay, I have a 3 and an 8. That multiplies to 24. And 3 plus 8 also adds up to 11. So now I'm going to replace, remember we replace your 11x with 3x plus 8x. I'm going to replace this 11x here with the 2 that we just found. So doing that, I'm left with a 2x squared plus a 3x plus 8x plus 12. Okay, so now I'm going to say, what can I take out from my first two terms? An x. When I take out an x, I have a 2x plus 3 left over. And I know that I have to have that same binomial left over, so I'm just going to rewrite it and say, okay, what do I have to take out from the last two terms in order to have a 2x plus 3 left over? Well, 8x divided by 2x is a 4. Let's make sure that works for both of them. 8x divided by 4, 2x. 12 divided by 4 is a 3. Alright, so then our last part here, we say, what did we make both of these have in common? We made both of them have a 2x plus 3, and therefore I'm left with an x plus 4 left over. Make sure that you multiply this out by using FOIL, and you will get back to this original quadratic trinomial. Moving on here, let's take a look at perfect square trinomials. So when we have perfect square trinomials, we're going to be looking at a perfect square trinomial here will have two different forms, and it goes both ways. So factoring perfect square trinomials means that your first term and the last term are going to be something squared or perfect squares. And then the middle term is 2 times whatever a is and whatever b is. And this is how you factor it. Okay? Then for this one, again, it'll be your a squared, perfect square here, a perfect square for your last term, and the middle term is a negative 2ab. So, let's try one where it is a perfect square trinomial. So we're going to use this here. So the first thing we're going to do is we're going to rewrite the first and the third terms as squares. So I want it to be something squared, and I want the last one to be something squared. Something squared. So this one is a 7, because 7 squared is 49. And this one, if I take the square root of 9x squared, I'll get a 3x. Okay, then I want to make sure, since this is a negative middle term, second term, I'm using this one right here. So I want this to be a minus 2, because it says 2, times whatever you got your a to be, which is a 3x, times whatever we got our b as, which is a 7. So let's make sure that this checks out. Okay, so rewriting the middle term to verify it, we want to make sure that it multiplies to be a negative 42x. So negative 2 times 3x is a negative 6x, and negative 6x times 7 is a negative 42x. So since it will be in this form here, we can now write it as a minus b squared. So we're going to write it as, we have our a, and our a is a 3x, minus our b is a 7, and this is factored. Okay, let's try one more like that. So for this one here, again, we want to write it as something squared for the first term and the last term, and then we will verify the middle term as 2 times your a times your b. So we say the square root of 4x squared is a 2x, the square root of 9 is a 3, and then we're going to put this 2x here and this 3 here to verify it. So 2 times 2x is 4x, and 4x times 3 is a 12x. So that is verified. We're going to use this first equation here, right here. So it will be a plus b squared. So my a is a 2x plus my b is a 3, all squared. squared. This is factored. If you cannot remember this formula, that's okay. You can still do the a times c that adds up to b, but as you can see, it gets to be pretty big numbers, so it's very helpful if you can remember your perfect squared trinomials. Moving on, another form that we need to know is factoring the difference of two squares. So if we have a difference, minus, and these are both perfect squares, it will factor to be where it's going to be a plus b times a minus b. We need to know this. This comes up a lot. And this is called the difference of two squares. Difference, we have two perfect squares, a plus b times a minus b. So factoring this, we do have a difference, and these are both perfect squares. This is an x squared minus an 8 squared. You don't always have to rewrite it like this, but just to show you how it is going to be both perfect squares. This will factor to be x plus 8 times x minus 8. Okay? This one here, we can write it as 2a squared minus 7 squared, and that will factor to be 2a plus 7 times 2a minus 7, and that is factored. Alright, and then finally here, if we take a little word problem, it says, suppose you cut a small square from a square sheet of cardboard. Write an expression for the remaining area. Factor the expression. Alright, so we know that these are both squares. We know that this length is x and this length is y. So therefore, this entire side here is x plus y, because this is x from here to here, and this is y from here to here. It's a square, so we know that both of them have a length of x plus y. We're going to be subtracting off, this is a y, and this is a y, okay? So we're subtracting off this entire area. So we're going to take the area of the big square, and then we're going to subtract off the area of the small square. Okay? So we know that area, we will just do the side, x plus y squared. And then minus, this little area is y times y, which is a y squared. Okay, we need to simplify this now. This we should know, we just learned this in the previous slide here, x plus y squared, we need to be able to go both ways. So instead of a plus b squared, it's x plus y squared. So we're using this form, which is a perfect square trinomial. You would have x squared plus 2xy plus y squared. So using that, this would be, because I know that x plus y squared is equal to x squared plus 2xy plus y squared. So I'm going to write that underneath here. X squared plus 2xy plus y squared. I'm going to bring this part down, minus a y squared. We'll see that these two will cancel out. Y squared minus y squared cancels. We're left with the x squared plus 2xy. You can leave it like this, or we really should take out an x, because they both terms have an x in it. So you have x times x plus 2y. And that is really fully factored there. And that's a wrap. Thanks for listening.